So welcome back. So sorry about the last video, it was cut short. So we'll continue from where we stopped in the last video. So that means since we are adding the two functions that are already DL'd together, we are going to have 1 plus x, because we are looking at the DL of exponential x, plus x raised to the power of 2 over 2 factorial, plus x raised to the power of 3 over 3 factorial, plus x raised to the power of 4 over 4 factorial. And we said that when dealing with factorials, factorial of 2 is just 2 times 1. Factorial of 3 is 3 times 2 times 1. And the factorial of 4 is 4 times 3 times 2 times 1. So factorial of 2, which is 2 times 1, will give us 2. So this is just going to remain 2. The factorial of 3, which is 3 times 2 times 1, will be 6. So instead of writing 3 factorial here, we're going to replace it with 6. The factorial of 4 times 3 times 2 times 1, 4 times 3 is 12, times 2 is 24, times 1 is 24. So instead of having 4 factorial here, we'll replace it with 24. So factorial is just, if I have 5 factorial, for example, it will be 5 times 4 times 3 times 2 times 1. So we are going to add this with our square root of 1 plus x. So this is part2 de x4. All of this plus square root of 1 plus x. We said the DL of square root of 1 plus x when n is equal to 4 is 1 plus 1 over 2x minus 1 over 8x squared plus 1 over 16x raised to the power of 3 minus 5 over 128 x raised to the power of 4 plus part2 de x4. So you can't see that, so that's it. So what we do is we just add these two together. So that means we have 1 plus 1, which is 2. Then the next we collect like terms. So here we have x and x. So we're going to do x plus 1 over 2x. Just do it here, x plus 1 over 2x. This is the same thing as x over 1. So when calculating things like this, to find the common denominator or the LCM, to find the common LCM, the common denominator in this case, we know if you multiply here by 2 and multiply here by 2. So whatever I do to the denominator, you do it to the numerator. If we multiply here by 2 and this by 2, we'll be having 2. So our LCM here is 2. So we're left with 2x plus x, because this is 1 times x. So we're left with x plus 2x, and we'll have 3x over 2. So we're having x plus 1 over 2x will give us 3x over 2. The next is the square. We're having x squared over 2, that's plus x squared over 2 minus 1 over 8x squared. So we have x squared over 2 minus 1 over 8x squared. Same thing, to have the common denominator here, since 8 is the highest, we know we can multiply this by 4 and multiply here by 4. So if we do that, we're going to have 4x squared minus x squared, which will give us 3x squared all over 8. So for the order of 2 here, we're going to have 3 over 8 x squared. That's plus 3 over 8 x squared. We continue adding. So in the third part, we are having x raised to the power of 3 over 6 plus 1 over 16 x raised to the power of 3. So we'll do it right here. So I have x raised to the power of 3 over 6 plus 1 over 16 x raised to the power of 3. Here we can, in this case, if you look at the denominator, there's nothing I can multiply with 6 that will give me 16. So the next thing you think is, what can I multiply with 6 and multiply with 16 that will give me a common denominator here? So if you look, the parts where they can meet is if I multiply this with 3, okay, and if I multiply this with 3, remember I have to multiply it here also with 3, and if I do that, that means 16 times 3 will give us 48. So to get 48 here as well, I have to multiply this with 8. So if I do this with 8, I'll multiply here as well with 8. So 6 times 8 will give me 48, and 16 times 3 will give me 48. So I'm now having a common denominator. And so 8x3 plus 3x raised to the power of 3 is 11x raised to the power of 3 over 48. So at the order of 3, we'll be having 11x raised to the power of 3 over 48. For the order of 4, it would be the same thing. I think we can clean this part where we've worked on already, so we'll have some space. This x raised to the power of 4. So we're having x raised to the power of 4 over 24 minus 5 over 128 x raised to the power of 4. So in this case as well, to find the common denominator, we have to multiply, look for what we can multiply with the denominator that will make us have a common denominator. So in this case, get the calculator. We have to multiply this by 3. If you multiply this by 3, we are going to get 384. So 128 times 3 will give you 384. You multiply here also by 3. And again, what can we multiply with 24 that will give us 384? That's 16. So we'll multiply this by 16, and so we'll multiply this as well by 16. So we are going to have 16. Remember, this is times 3. So we are going to have 16 x raised to the power of 4 minus 15 x raised to the power of 4 over 384. So 16 minus 15, we are left with 1. So we are left with x raised to the power of 4 over 384. So that means this will be plus x raised to the power of 4 over 384. Let's just write it. So we are stopping at the order of 4. So whatever is left, we just place it to be in our rest. So we just bring back our petit todo x or cat. The only difference is that when you are not using this other, I just use the green marker so that I can see it clearly. Whenever we are not using this method, because we know whenever you use this method, you have to also include where the limit when x don't verse 0 of epsilon of x is equal to 0. But if you are not using this and you're replacing it with part2 to xn, you don't have to include this condition. So finally, write this. The dl over zinage to 0 of, this is of, f of x equal to exponential x plus the square root of 1 plus x is equal to 2 plus 3 over 2x plus 3 over 8x squared plus 11x cubed over 48 plus 1 over 384 x raised to the power 4 plus part2 to x raised to the power 4. So this is the dl aloducat of exponential x plus the square root of 1 plus x. Now, in case if you find it a bit difficult to use the method I used to find the common denominator, I'll just quickly show us another way to find the common denominator. We used that when we were back in secondary school. That's what we normally use to find the LCM of numbers. So I'm going to use for the order of 3. We had x raised to the power of 3 over 6 minus x raised to the power of 3 over 8. Right? That's 16. 16, and this was a plus. This was a plus. Alright, so in this case, like I said, there's nothing I can multiply here that will give me 16. So I have to look for that way, and then I ended up multiplying by 3. We can be like, but how? If that method is not, you're not very familiar with it, you can use this method I'm going to show us now. You draw a table like this, you put your 6, you put your 16. Then you look for the smallest number, not 1. We don't start from 1. So you look for a number like from 2. And it has to be natural numbers. So you pick from 2. You can't pick 0, you cannot pick 1. So we start picking from 2. So we check if we divide over 2, are we going to get a whole number? If we divide here over 2, are we going to get a whole number? Yes, we will. Because if we divide, so that means we are going to start with 2. If we say 6 over 6 divided by 2, that's 3, right? So we have 3 here. If we say 16 divided by 2, that's 8. So it can work. So we write down 8 here. That's the first step. Then we check again. Can 2 again divide any of them? Now 2 cannot go in 3. We'll be left with decimal like numbers after the decimal, after the whole number. So can 2 go inside 8? So if we have 8 over 2, we'll have 4. So yes, so we can use 2 again. But because here it cannot work, we'll bring down the 3 and then replace this other side with 4. Now we look again. Is it still possible for us to use 2? Yes, here. Because if we say 4 divided by 2, we'll be left with 2. Here it won't work again, so I'll bring down 3, and so here I'll be left with 2. Again, 2 can go, because if I say 2 divided by 2, I'll have 1, so I'll have 2 here, 1, 3. Now can 2 go here again? Remember, we can't use 1. 2 cannot go here, neither here as well, so we go to the next number, which is 3. Can 3 go here? Yes, so we use 3. We'll have 1. Here we won't use 3, because we know we are going to have a decimal, so we bring down the 1 in its own. So we are left with this. Okay, so what we do now is we take this part, that's all the things we use to divide, and we multiply all of them. The multiplication of all of them will give you the common denominator. So if we multiply 3 times 2, we get 6. 6 times 2, we get 12. 12 times 2, we get 24. 24 times 2, we get 48. So the common denominator will be 48. So at this point, what are you going to do next? Now you have a common denominator as 48. To find the sum of this, what we do is we take 48 and divide it with 6. That's 48 divided by 6. And 48 divided by 6 is going to give us 8. So here will be 8. So we'll multiply here by 8. Same thing here, 48 divided by 16, we'll get 3. That's 48 over 16, we'll get 3. So we'll multiply here by 3. So that means we're having 8x3 plus 3x3. So that is 11x raised to the power of 3 over 48. So that's why it's either you use this method, or if you're good with the common denominator, you can try it out as well. But with practice, you'll get used to both methods. So thank you for watching. If you have questions or anything you don't understand, you can put it in the comments below. And don't forget to subscribe and share. So thank you for watching, and see you in the next video.